Okay, we have here to another integral from the Berkeley Math Tournament 2024, problem number 7. We've got the integral from 0 to 1/2, 1 over 1 minus x to the 1/2 times 1 plus x to the 5/2 dx. Okay, this is my second attempt at this one. The first one went pretty long, and I said in that other video I wanted to do kind of a short method and a long method. Well, hopefully this is going to be the shorter method, or at least it seemed that way when I did it on paper. So to get started with it, what I want to do is just a u substitution for only this piece right here. So I'll set u not equal to just that, but we'll do it as 1 over that. So I'll set my u equal to 1 over square root of 1 minus x. And then before taking the derivative, let's solve for x. So I'll take the reciprocal on both sides. We have square root 1 minus x is 1 over u. Then square both sides, 1 minus x is 1 over u squared. Solving for x, we get x is just 1 minus 1 over u squared. Take a derivative on it. Our dx value is going to be just minus 2 over u cubed du. Or rather, that's going to be positive, so let me fix that. And then one more value for this chart over here. Let's just get 1 plus x. So just adding a 1 on this on both sides, we get 1 plus x equals 2 minus 1 over u squared. So then we'll go ahead and substitute. First, we'll take 1/2 and plug it in here. So if you do that, you're going to get, this becomes square root 1/2. Flip it and we get square root of 2. Plug in 0, this thing's just a 1. Then for our dx value, we're going to have this thing. For the 2, let's bring that up front as a constant. And then, let's see how this is going to look. We'll write it as 1 du, and I'll bring the u cubed over here for now. Now this left part here, 1 over square root 1 minus x, that's just going to be our u. So actually, that's not a 1. Let's write that as a u. And then this part right here is going to be this 2 minus 1 over u squared to the 5/2. And then now this thing is still kind of a mess. I want to clean it up. Particularly, I don't really like having 1 over u squared right there. Now, if I could make this into u to the 5th, that's going to work nice with this. So to do that, all I need to do is multiply in u squared. So I don't change it. Let's do the same thing in the numerator. So now this right here is u to the 5th. But how I can write this, what if I did it like u to the 5/2 squared? Then by exponent properties, I can just kind of reverse these. And so that's the same thing as u squared to the 5/2. So let's just rewrite this using u squared to the 5/2. And now that we've got the same exponent on this one and this one, I can just multiply this in. And so what's going to happen when we do that, that's going to cancel here and give a 1. And then I can just multiply it on the 2 here. So let me clean it up and see what we have. Multiplying together the numerator, we end up with u cubed here. 2 times u squared, that's just going to be 2u squared. Again, this is going to be just minus 1 all to the 5/2 du. And then here I can just do another substitution to clean this up. Because if I get this down to just one variable by doing a substitution for all this, then it's just going to be power rule. So we don't need any of this. So for this substitution, we'll use a different variable. Let's call this t. So we'll say t is going to be 2u squared minus 1. And then take a derivative, dt is going to be just 4u du. Now, we don't quite have it set up. So I think what I want to do, we just multiply it together, but let's split it apart again to create this 4u. So I'll force this in right here in order to get the du. So that I'm not changing it, I need to multiply by u squared in 1/4, because this right here was u cubed. And the only other thing I need is, let's get a value for u squared. And actually we have this 2 hanging around. So this is real easy. I can just add 1 on both sides here. And so then 2u squared is going to be t plus 1. So then just making it clear, let's take the 1/4, bring that out front, and bring the 2 in. So I can write like this, 1/4 out front, 2u squared. So then we have our value here. Go ahead and substitute. We've got 1/4 in front. Plug in square root of 2. This here is going to become just a 3. Plug in 1, end up with 2 minus 1, or just 1. 2u squared is this, t plus 1. This thing's a t, so we have t 5/2, and everything else is just dt. So then let me just multiply this into the numerator. I'll split this into 2 integrals. So we're going to have integral from 1/4, 1 to 3. The first one, that's just going to become t minus 3/2 dt. Second one, distribute in the 1/4. 1 over t to the 5 halves, I'll write it as t minus 5 halves dt. One reason I think this method is faster is because notice the bounds are just integers, so it's going to be easy to evaluate. And the other one we had like 2 minus square root of 3 and it was a whole mess. So I think that's going to help. So now we'll just go ahead and integrate, but actually, I should have left the 1/4 out, but I'll factor the 1/4 out front of everything. Integrating this first one, we get minus 2 over square root of t. This second one, we get minus 2/3 to the t minus 3 halves. Let's write this. I'll get the square root again. I don't know. You could do it either way, but let's just write it like this. It's easier. I just like calculating it this way. And then we just need to evaluate this from 1 to 3. Then before I evaluate, let's see if I can simplify it. So for this thing, I can break it up like t squared times t. Inside the square root, that's going to be the same thing as t squared root of t. So let me just write this like this. And then I can get a common denominator here, multiply in 3t. If I do it up here, it's going to become minus 6t. And let's factor out a minus sign while we're at it and put it out here. So now putting this together, what we're evaluating, minus 1 over 4, 6t plus 2 over 3t squared root of t from 1 to 3. So let me just clean up the board and we'll evaluate this thing right here and we can finish it off. Okay, so we'll go ahead and we'll start by plugging in a 3. What's going to happen, we've got minus 1/4, and then the numerator becomes 18. Here, 3 times 3 is 9, square root of 3. Then for the next part, minus times minus is plus, so we got plus 1/4. Plug in 1, you get 8 over, that's just a 1, so this is just 8 over 3 here. We'll change the order, simplifying this. This becomes 2/3. And I see I made a mistake. This shouldn't be an 18. If you plug 3 in, you're going to get 18 plus 2 is going to give a 20. Multiply minus 1/4 times 20, you get minus 5 over 9 square root of 3, and that's it. Okay, there you have it. Thanks so much for watching. Have a good day.